Our next type of compound refers to a group of compounds that contain polyatomic ions. Now, we have talked about these previously as far as learning how to draw their Lewis dot structures. So a brief review. So what is a polyatomic ion? Okay, this is a group of atoms they're covalently bonded but they require electrons to complete the octets, the 8 valence electrons of all the atoms. Okay, there's one exception, and that's a polyatomic ion called ammonium. And ammonium has the opposite problem. They need to give an electron. Okay. These are charged groups. Like I said, most are negative because they have to take, if they're going to require electrons, it means they're going to become negatively charged. Again, the exception to this is the polyatomic ion called ammonium. Now, if you take your periodic table and you turn it over, you will find that there is a list of the polyatomic ions that you will be responsible for. Now, let's look at some of those. So for example, this group, which is 1 nitrogen and 3 oxygens bonded together, has an oxidation state of -1, meaning it needs to take 1 additional electron. Now the names of the polyatomic ions are usually based upon the first element that you'll see in the polyatomic ion. In this case, the name is based on the nitrogen, but the name for this group is called nitrate. Now if you look close by, and this is where sometimes polyatomic ions can get confusing. There's another group that looks very similar. It's nitrogen, oxygen. It even has the same oxidation number, but look, the number of oxygens is not the same. So the name has to be different to distinguish the two. This one is called nitrite. So you see these are the two most common endings for polyatomic ions, ATE and ITE. Notice this is not IDE. NITRIDE nitride is not polyatomic. That's N minus 3. So this is where it tends to get a little bit confusing. You have nitrate and nitrite, and then you have nitride. And these are completely different ions. You have to be really careful not to get them mixed up with each other. Okay, we do see a couple of them, though, that have the IDE ending. There always seems to be some exception to the rule that seems to make things confusing. For example, this is the polyatomic ion that gives students the most trouble. This is OH -1. This one doesn't follow any of the normal naming rules. The name doesn't begin with anything that has to do with oxygen. The name actually begins with something that has to do with hydrogen, and then it has something to do with oxygen. So this particular group, which is called hydroxide, breaks all of the naming rules. Yeah, it has the oxide. So students tend to think that this is, when they see hydroxide, they think HO. And it's backwards, it's OH. And this one has an IDE ending, or most of the polyatomic ions are ATE or ITE. So you might want to put a little star by this one on your periodic table, because this one's going to give you trouble if you don't remember it. You have to become familiar with these polyatomic ions. You don't have to memorize them. They're on the back of your periodic table for you to refer to at any time. But you have to start recognizing that this ATE and ITE ending means something different in most cases than the IDE ending. But then you also have to remember these weird ones that don't follow the rules, like hydroxide. This is a polyatomic ion. This is not hydrogen. Hydride would be hydrogen. It's not polyatomic. This would be H-1. This is called hydride. Hydroxide is this. Remember, oxide is just O-2. So you have to be really careful with those. Okay, so now that we have a list of polyatomic ions in the back, how do we end up writing formulas and naming them? Usually, since most of the polyatomic ions are negative, they're always going to come second in the formula, which means they'll also come second in the name. That means they're going to be paired in the compound with a metal. So you're going to name the metal. And if you happen to find one of your metals is a transition metal, you have to remember, don't forget a Roman numeral if it's a transition metal. And then you simply name the polyatomic ion. You don't have to alter the name or anything, you just look it up. The trick is you have to learn to recognize not only the names of the polyatomic ions, you have to recognize the groups within a formula. Now, the thing to remember is that since it's poly meaning many, that means look for 3 or more elements in the formula. Okay, that's your first clue when you're looking at chemical formulas, that there's a polyatomic ion in the formula. There's 3 or more symbols. So far we've talked about the binary compounds, the simple binary and the transition metal compounds. Okay, I've just had 2 elements, a metal and a nonmetal. Now we're going to look at a metal and 2 or more nonmetals. Okay, so let's look at some examples of that. Okay, so you look here and you say 3 symbols, Na, N, and O. 3 symbols, polyatomic ion. So you look here and you know that the metal is almost always at the beginning. Well, Na, well that's a metal. You should start recognizing some of these by now. That's sodium. So that means that this piece here has to be the polyatomic ion. So you go into your, look at the back of your periodic table and you say NO3. Ah, okay, NO3 is called nitrate. So this is called sodium nitrate. Okay, let's look at some ones that are a little trickier. Okay, and you look at this and you go, whoa, there are 4 different symbols, K, C, H, and O. I know there's got to be a polyatomic ion in there. Many atoms. That's a lot of atoms. A lot of different kinds of elements. Okay, look here at the beginning and say, okay, this is K. I know K is potassium, so that has to be the metal part of the compound. Okay, well, what's this big thing here? This is one big piece. Well, you look at the back of your periodic table very carefully, and you will find C2H3O2. A whole big group. is called acetate. Acetate. So this form is called potassium acetate. Alright, let's look at this. Okay, so I've got N and H and Cl. 3 elements, polyatomic ion. Now you look at the beginning here and say N. N is nitrogen. Now wait a second. We're supposed to be metals at the beginning, so what's going on here? Okay, you say, well, what on earth is this then? N and H. Okay, I'm going to look on the back of my periodic table and see if I can find, I know there's a polyatomic ion in here. What is it? If you look on the back of your periodic table, you're going to find that here's this compound, NH4. Now why is this at the beginning and where's the metal? Well, this is ammonium. This is the only polyatomic ion that has a positive charge, which means it behaves like a metal. It has to give away an electron to a non-metal. So I'm trying to show you some of the trickier compounds. So this one is ammonium, and that's just chlorine, plain old chlorine. Chloride. Okay, let's look at a couple more. Okay, 1, 2, 3 elements, Li, Cl, and O. Okay, here at the beginning, Li, that's lithium, so that's my metal. Write down lithium. Okay, that means that the rest of it has to be the polyatomic ion, ClO. So you look at the back of the periodic table, look around, and you say, where's ClO? ClO is called hypochlorite. Okay. See, there are 4 different polyatomic ions that start with chlorine. They have different numbers of O's. This one has 1, and then there's one that has ClO2, ClO3, and ClO4. So if you look at, they have to do something with the names to make sure, how do we know which one it is, which chlorine and oxygen polyatomic ion is it? So their names are all slightly different. This one's called hypochlorite. If there's 2 oxygens, it's called chlorite. If there's 3 oxygens, it turns into chlorate. And if they put 4 oxygens, that's called perchlorate. Alright, now let's look at writing the formulas. It seems that everything after simple ionic compounds has one little quirky or odd thing. For polyatomic ions, it's that if you need more than one of the polyatomic ion groups, so if you need more than one polyatomic ion, so you need 2 ammoniums to balance out a negative charge, then you write the formula in a set of parentheses. Okay, let's look at some examples for that. Oh, some different. Sorry, I'm going to erase that. Give me just a sec here. Alright, let's do magnesium nitrite. Okay, so I have to write the formula for magnesium nitrite. Well, this is easy. This is magnesium, Mg, and the oxidation state is 2. Nitrite. We look up on the back of the periodic table. It says NO2. Alright, this must be a 2. NO2, and that's -1. Okay, so these are ions, and I say, okay, I have to add up to 0. +2, well, this one's -1. So when I do my switching, I know that there's going to be 2 here and 1 here. Be very careful that this 2 here has nothing to do with this 2. I need 2 of this entire group to balance out the magnesium. So when I write the chemical formula, how do I write that I need 2 NO2s? I'm going to put the entire NO2, and then I'm going to put another 2 on the outside. Okay? Because if I just wrote NO2, that's just 1 NO2. That would just be -1, and this would not be a balanced compound, would not balance out to 0. So anytime you're switching the oxidation numbers to get the ratio correct, you need to put this in parentheses, then add on whatever number you're going to switch. Let's do a couple more examples of that, because that tends to be a little confusing. Okay, this is called aluminum sulfate. Okay, so aluminum sulfate, here's aluminum, plus 3. Here's SO4, sulfate. If you look on the back of your periodic table, you'll find SO4, and its oxidation number is -2. And if you're confused about where these numbers are coming from, look at the back of the periodic table. Both the formula and the oxidation state for every polyatomic ion are found on the back. Okay, well, how do I write this in a formula? Well, this is +3 and this is -2, so those don't add up to 0. So I'm going to have to switch the numbers. So the 3 is going to go here and the 2 is going to go over here. So it's going to be Al2. Well, here's SO4. We're supposed to put a 3 on it. You can't change to SO4. You can't change it to SO3. SO3 is not sulfate. So I'm going to have to put the SO4 piece in parentheses. Then the 3 for aluminum can go here. Okay, so you have to watch the parentheses. Now, you don't always need parentheses. For example, what about strontium carbonate? Okay, strontium, you look on your periodic table, that's Sr. It's +2. Okay, carbonate. Remember, carbonate is not carbon. Okay, it has carbon in it, but it's not just carbon alone. Carbonate, ATE, that's a clue. Look on the back of your periodic table. Okay, when you look at the back of the periodic table, carbonate is called CO3, and it has a -2 charge. You look here and you're like, +2, -2. Hey, those two cancel out. That means the formula is just Sr CO3. I don't need to put any parentheses around the CO3 because I just need 1 carbonate to go with the 1 strontium. So you're only going to need these parentheses if you need more than 1 polyatomic ion in order to make the compound balance out to 0.